In this video, we will learn how to analyze a dataset using big data tools like Apache Spark and Cassandra and our language. Apache Spark is a fast in-memory data processing engine. It can access diverse data sources like HDFS, Cassandra, HBase, etc. Apache Cassandra is a highly scalable, high-performance database designed to handle large amounts of data across many commodity servers, providing high availability with no single point of failure. It is a type of NoSQL database. It can also deal with unstructured data. So we download our dataset from GitHub. So there is a user named Chris Albon. From his repository we download a dataset named The War of Five Kings. It is inspired by the fiction written by George R.R. Martin, The Game of Thrones. This is the dataset, and this is how it looks like. It is a CSV file. It has the name of battles, years, the battle numbers, the attacker king name, the defender king name, the attacker 1 name, attacker 2, attacker 3, defender 1 name. Similarly, the attacker outcomes, win or lose, battle type, ambush, pitched battle, siege, major deaths, major captures, attacker size, and etc. You can do various predictions using this dataset. This is a very interesting dataset. You can probably predict which king was most vulnerable, which king was most prone to attacks, and those kind of stuff. You can probably fit some statistical models in the dataset. Here we will do very simple analysis. We'll find out the kings who carried out the most number of attacks, and the region which saw the major bloodshed. So we will SSH into the Cassandra container first. For that, we get into the BigDataLab host where the services are running. Now this example is present in the BigDataLab sample app repository, which you can find here, home/dceng. This is the path of this BigDataLab sample apps folder. You can find this example in that particular folder. Now you go inside the Cassandra container. We download curl. Curl is a software which will help us to download this dataset into the container. Using curl, we'll download the dataset. It is a CSV file, as we saw. The dataset has been downloaded. Now we run a simple Perl script to update end-of-line encodings. Now we open SQL shell. So SQL is a language which helps us to interact with Cassandra. We create a key space named Game of Thrones. You can assume key space to be similar to database in MySQL. We create a table in the key space named battles. With respect to the data which we have, you can see battle number, attacker. It is similar to the data which is present. So it fits the schema. We populate this table with the dataset which we had downloaded. So it has been populated. We exit the Cassandra container now. Now we'll log into the Spark master container. You can find the port number and relevant information in the user documentation. We go inside the Spark directory. Then we start the Spark shell with the master IP, which you can find in the documentation. We download this Spark Cassandra connector and we give a configuration to the Spark context which will be started by the Spark shell. You can also provide the configuration after the Spark shell has been started by stopping the Spark context and starting it back again. I'll just show you how you can do that. So we can go to the Spark master UI and see there are three workers here: number of cores, the memory, and there should be a running application here. Yeah. So there is a Spark shell running which is using 30 cores right now. It has been configured to allocate the resources dynamically. So as per your requirement, the resources will be allocated. Right. So the sorry. So we import the necessary packages here. So yeah, you can basically stop the Spark context using this command, and then you can rerun the Spark context with the by specifying the configurations if you want. But we skipped that step, and we have provided the configuration at the start of the Spark shell only. So we import the necessary packages. Now we create a data frame which will read data from Cassandra, from the Game of Thrones key space and battles table. Then we will print the data frame on the console. So you can see the course has been 10 now, so it is a dynamic allocation. So this is the data which we had populated earlier on in the Cassandra table. Now it's time for some analysis. We will see which king carried out the most number of attacks. So we will create a data frame using this command, which you can find in the documentation. Then we'll print the data frame here. So you can see the attacker king's name and the attacks he carried out. So we can see Joffrey or Tommen was the most aggressive king, or the king which carried out the most number of attacks. Now we can also find the kings which were attacked the most. So we create a separate table for that. Then we select the defender kings. So Robb Stark was the king on which the most number of attacks were carried on. Now it's time for some Spark R related analysis. So we'll quit the shell, and you can see the Spark shell is now in the completed applications section. Now we will start the Spark R shell with the same packages, master, IP and configurations. So then we'll create a data frame that will point to the Cassandra table, and we'll create a temporary table out of it. So these are some warnings which you can ignore for now. These won't affect the tutorial here. You can see there should be another application running. The Spark R shell is running now with 30 cores. This is the application ID. Then we create a table. Then now we are finding out the region which has seen the most blood. It means the region where the most battles happen. Then we run this command. Now we can see on the UI So this is running, and if we click on this application, we can see the number of executors, their ID, the course they use, their state, and everything. Go back. So yeah, these are the regions on which saw the respective number of battles, and the Riverland saw the most number of battles. So we can say that it saw the major bloodshed, the most bloodshed. Now, using this data set, as we mentioned earlier, you can probably fit some statistical models and find out interesting informations out of it. Uh, like, what is the probability that Rob Stark will be attacked again by, say, uh, Joffrey or some other king? So, using Bayes algorithm or probably some other statistical tools, you can do that. Now, it will be interesting to see what you can come up with.